Okay, I turned this off like 2 hours ago, and I don't know if there's people actually here, but whatever. Mic check. There's no music because my computer said it needed an update as soon as I'd set all of this stuff up, so that's annoying. So there won't be any music, just be me. But I'm just going to go over some of the terminology well, I guess you would have seen in the exercise yesterday. Uh, and I didn't really cover it because I kind of wanted you to think about it before I guess, gave it a math context. So I'm going to go over each of these terms, and you would have seen each of these in the exercise. So let me start by just drawing two parabolas. Draw a happy one and a sad one. So now, the vertex. You might think of a vertex as like, I guess, in a shape, like the part where it turns, I guess is one way of thinking about it. So the vertex is actually the part where the parabola turns. So this point here and here, they're vertexes. Call that one, call that two. I mean one. So I'm labeling it in terms of that. There is someone here. Hey, Krish. Okay, concave up. Concave up means that it's kind of how do I put this? If you thought of it like a cup and it was like facing up, I don't know how else to explain that, but it's kind of going like the arrows are in the up direction. So concave up means it looks like this. It's just like a smiley face. So I think of concave up as like a smile. So smile, and that's this parabola here. So that one's concave up, and I guess conversely, concave down means like a frown. So I guess down, you might be sad or something like that. That's this parabola. A minimum. So if a parabola has a minimum, that means it's got a lowest point. So I guess if you look at this one, it doesn't have a lowest point because I haven't drawn it on here, but there's arrows that suggest this goes on forever. It doesn't have a minimum. In fact, its minimum would be negative infinity. So these things go on forever, whereas this thing actually has a minimum. It's this point here. So that point there is also a minimum. So I can call that 4 as well. And again, conversely, a maximum just means, does a parabola have a maximum? Well, this one doesn't because it seems to go on forever. This one's got a maximum because it stops here, and that's the very highest point. So that's the maximum there. So I'm going to call that 5. So that means it's got a lowest point, and this one has a highest point. So if you were asked, what's the maximum of this? Well, there's two answers. One, it doesn't have one, or you could say it's infinity, because this just kind of goes up to infinity. A turning point, again, that's just this. Whoops. That's just this. So I guess there's a lot of different names for this single point that is on the parabola there. So that's a turning point, and so is that. So I guess the point where your parabola turns is, yeah, it's the vertex. It's also a turning point. It's also perhaps the minimum. In this case, it'd be a maximum. Now, the axis of symmetry is, I guess, exactly what you'd think it'd be. That, which is 7. And in the last exercise, we're only going up and down. So the axis of symmetry never actually changed. Oh my God. Hi, Alistair. So the axis of symmetry never changed because our parabola, if you just grab this, it was just going up and down, and the axis was just the y-axis. Whereas we're going to be looking at moving it left and right today, so the axis of symmetry is something that's going to change, and it's something that we're going to be able to calculate. All right, so in terms of moving it left and right, it's a little bit different than you might have seen before, and I'm going to show you why kind of towards the end. But for now, I just want you to kind of think about the 3 types of parabolas, and this is as far as we're going to go in year 10 in terms of parabolas. We will go a little bit further next year, but for now, here's our original. So as long as it's an x squared, this a just, actually I'm going to write this. So here that just changes how wide / narrow it is, or you can think of it as the gradient. So in a straight line, it wouldn't have this, it'd have an m there, and that would be the gradient. This one's the same, so again, that's just how wide and narrow it is. This just tells you how up or down it is, but it also tells you what the y-intercept is. Now in the left and right case, instead of having a plus c on the outside of the whole thing, this time we've got a minus c, and I'll explain why it's a minus in a sec, a minus c that's inside the brackets next to the x. So in other words, in here, we're just like opening up this part of it and putting a c in there. That's what's kind of happening. So this moves it left and right. And what that will tell you is where the axis of symmetry is. Axis of symmetry. So if you think about it, if I just had like a parabola here and I started, actually let me grab this. If I had this parabola and I moved it left and right, the only thing that's really going to change is the axis of symmetry and the turning point. So you see here the turning point is whatever that is, and I move it here and the turning point obviously changes. So changes the axis of symmetry, also changes the turning point, and it also changes the vertex. So it changes a lot. Krish, why do you have so many accounts? Yeah, that's, yeah. All right, let's actually draw some. So let's go with running out of room already. I didn't want to use one page. Let's just go with y equals, what is the exercise have? X minus 1 squared. Okay, so it's pretty much a set of brackets that have a squared in it. That's pretty much all we're going with. I'm only going to do 3 of these. Let's label stuff. Let's be proper. Okay, so I always draw the original. I've already got, I don't have the original. Yeah, let's just draw it. The original always just looks like your good old x squared sitting there. Let's call that, let's give it a name, y equals x squared. Now, this minus 1, it's going to be a little bit confusing because when we had this here and we said that that was a plus 1, it went up in the positive direction. Now I've got a minus 1. You might think, okay, well, this is actually going to go in the negative direction. Wrong. That's not correct. I'll show you why in a second. But when it's a minus, it actually moves it to the right. So, and that might be a little bit confusing. So that means I go to the right by 1. So my new graph is going to look like, well, definitely not like that. Please stop doing that. There we go. It's going to look like this, where this point here is x equals 1. And that's literally it. That's all I really need to draw. I could call that point a couple of things. I could call it 1, 0. It's also the vertex. I guess that's it, really. Now that's, I guess, your most simplest example. What if now I had y equals minus, and then let's go x plus 2 squared. So let's kind of do a bit of a 2-in-1 here. This is really weird without music. It seems really eerie. It seems a little bit boring too, but oh well. Okay, so again, I'll just draw my original with that. Oh, that seems a little bit too thick. Why does it keep making that? If anyone's wondering, we're going to be at some stage looking at a graph that actually does look like that. Not yet though. Okay, that's y equals x squared. Y equals x squared. Any comments? Oh, I've got 6 people and I haven't even posted the link. That's ridiculous. Okay, now let's think about all the things that have happened to it. What does this minus tell us? Well, it actually tells us it's upside down. Okay, so it's not even going to look like this. It's going to look like this. But the same thing. This plus here, you might think, okay, I have to move it in the positive direction. Wrong. You actually move it in the negative direction. So this thing's making it go left. So it's going to be upside down and left. So upside down and left. Why do I keep drawing triangles? Why do I keep drawing triangles? Thank you. Oh, it's going left 2. So this point here is going to be minus 2. And that's that. I hate how that's not even. Still not even triggered. Okay. Now, last one. I did have here, there we go. I did have here an A out the front, and none of these have an A. I guess that kind of does. It's got a minus 1. But let's put a value out there and see what happens. You should be able to guess what's going to happen, but this is going to be a very messy. Let me move stuff. Move out the way, please. There we go. God, it's quiet. Oh my God. I want to take, I didn't even close that bracket. I'm having a shocker. Close. Okay. Y equals, what do we want? To thank me for being 3 of them. Thanks. Yeah. Let's go 2x plus 1 squared. All right. Graph. Terrible. Y. X. This isn't even. Oh well. That's going to trigger me. Anyway, I'm not going to draw the original this time, but the original is going to look like this, right? That's x squared. Now, actually, let's draw the original because I'm going to need it every time. There we go. Okay. Now, let's just go with the obvious one. This one moves it left. Now, what does this 2 do? That actually makes it skinnier or narrower. So that makes it, let's go steeper. That makes it steeper. So it's going to be a little bit thinner, and it's going to be to the left one. So it's going to be like that. So let's hope I can actually draw one properly. There, that's thinner. Yes, thank God. Okay, so it's like that. That cuts at 1. And that's it. So that's literally it. All you need to know is how to move it left and right and how to move it up and down, but you're not going to be asked how to do both. So, yeah, I guess you could imagine that these could all have like a +2 on the end. The only difference would be I just grab this and move it up 2. So it'd be like that. That's the only difference. So the graph that looks like a V is an absolute value graph. Yes, that's correct. That wasn't necessary, but yes, it's correct. I can show you why that is, but for another time. What was I going on about? Yeah, we're not moving up and down. We're not moving up and down and left and right. You're only going to be asked to do one at a time. So yeah, I guess that's all you really need to know. Now, why is it a minus and not a plus? I'll show you. This is, you can stop here if you want, but this is a little bit of extension as to why. Let's actually write y. Well, think about this. If I've got y equals, let's go x squared plus 2, we know that that is an up. It's an up. It's raising the graph up. Oh my God, up 2, right? Now, what that's actually doing is it's affecting the y coordinate. So if you think graph, there's y, there's x. What it's doing is, where's my x squared? It's affecting where the graph goes up and down on the y-axis. And the reason here is if I just rearrange this quickly, I've got y minus 2 equals x squared. And this seems really stupid, but I can chuck brackets around that. And it's whatever I can chuck brackets around, that's actually what it affects. So see how I've got y minus 2 and it goes up. It's changing it so that it's changing, like it's kind of the opposite. I don't know how else to explain it. It's next to the y, I guess. It's next to the y, and it's affecting the y by taking away 2 from what it used to be. So now that actually raises it 2. I don't know if that made any sense, but that's a 2 now. And so the same argument can be made for the y equals x minus 2 squared. In this case, the thing that's being affected directly is the x. See how the minus 2 is right next to the x? That's why it moves it left and right, because that's the x coordinate, like that's the x line, I guess, is one way of thinking about it. So if I draw another parabola, x minus 2 moves it to the, stop drawing absolute values, stop drawing whatever the hell that is. Okay, draw one slowly then, triggered. Thank you. X minus 2 moves it this way, and that's minus 2. So it kind of, yeah, I don't know how else to explain that. But yeah, it's kind of like if you're confused as to whether this moves it up and down or if this moves it up and down, just think about what it's directly affecting. If I were to move that, it's next to the y, so it changes where it is on the y-axis. This is right next to the x, it changes where it is on the x-axis. If I guess another way you can think about it is, you know how before when we were doing x and y intercepts, and I said, let's go with this one. If I want to find the x intercept, I make y equals 0. Well, when I do that, I've got 0 equals x minus 2 squared. If I square root everything, I've just got 0 equals x minus 2. And then I've got, whoops, and then I've just got x equals 2. And that's where it is on the x axis. Oh, I've just buggered that. That's actually moving it that way. Sorry. That's there. So that's kind of why it's the opposite, because when you go to rearrange it, it is the opposite, and the same can be made for this argument. So if I wanted to know whereabouts on the y-axis it is, I'd make x equals 0. So then y equals 0 squared plus 2, which is just y equals 2, which just tells me that it's up there. I don't know, I feel like I'm just rambling, but I think it's kind of interesting to think about why it's the opposite. And it's the opposite because I'm looking for a coordinate, and it just so happens that the x coordinate is right next to it. Because at some stage when this is 0, you're going to have to move this, and at some stage when this is 0, you're going to have to move this. So that's why you can think of it as being the opposite. You get it now. Anyway, all you really need to know is that when you move it up and down, yeah, it does kind of make sense. When you're moving it left and right, it might not make too much sense, but that's kind of because the thing that it's directly affecting is on the same side of the equation as it, whereas in this case it's not, so that's why it does make sense, because this all just disappears, and it tells you exactly where the y-coordinate is, but when all this disappears, this doesn't tell me much, because that's just going to be 0, so I still need to move this, and then in doing that, now it's going to make sense where it goes, because that's going to be plus c, which is going to move it to the right, which is what it was supposed to do. So that's, yeah. Yeah, I found a really hiding spot, Alistair. So yeah, anyway, I don't know what else to say about that. Moving it up and down makes sense. Moving it left and right doesn't really. But yeah, you won't have to do both. But you can do both. It's not really that hard. I guess if we did an extension question, let's do that since people are here. Let's go, like, I could make it as complicated as possible, like minus 1 on 2 x minus 3 squared plus 4. Like, I can graph something like that. You guys should be able to graph something like that, but it's beyond what we're doing. But it's not hard. I just got to think about all the things that are happening to the original graph. So let's do this for fun. I've got y. This is probably something I would have liked to have done in class and see what people come up with, but oh well. I love it if people were able to like try right now, but then I can't really see what people are doing, so that kind of sucks. But if I've got y equals x squared, that's not what I want, x squared. Just think about all the things that are happening to it. So this tells me it's upside down. That tells me that it's wider. That tells me that it's to the right 3. And that tells me that it's up 4. Okay, so if I do all of that, if it's, how am I going to do this? Let's just do it upside down and wider. So upside down and wider is going to be, let's go like that. Now it's to the right 3, so that means it's 1, 2, 3, and then it's up 4. 1, 2, 3, 4. So that point is the point up, so 3, 4. It's got an axis of symmetry of x equals 3. That's it. Again, you could find this. That wouldn't be hard. If I wanted to find the y-intercept, I make x equals 0. When you do that, that's 0. So now I'm just solving this like an equation. What's half of 9 is 4.5 plus 4 is 8.5. So that point there is 8 point. Oh, that doesn't make sense. It's wait, what? That didn't make any sense, did it? That should be, no, that's minus 4.5 plus 4, negative 0.5. Oh, okay, so the y-intercept should be down here. But you get what I'm getting at. We can start using all the things that we've, I guess, looked at in terms of graphing, and we can graph things pretty accurately. So let's go with the challenge question. Let's go. I'm going to leave this to you guys. Challenge. Y equals minus 1 on 3 x plus 8 minus 3, and a bonus, find x and y intercepts. Okay, if anyone can do that, I'll be impressed. Let's make that. Should we make a second one? Let's make a second one. Y equals 8. Oh, that's got to be squared. Whoops. Oh, I've got a squared there. 8 x minus a half squared plus 4.5. Have a go at those two. Okay, are there any questions before I leave? I know there's 6 people somehow, but I don't feel like it's too hard, but I've just probably made it harder, so I apologize for that. Oh, let's look at this. So if I move C, oh no, why is it doing that? It's not factorized. Well, that was a fail. It hasn't factorized it. I had it in brackets, that's annoying. Yeah, look at my equation. Y equals minus x minus C. Oh well. Okay, no questions? Nothing, 20 minutes, oops. This was supposed to be a short video. Well, that didn't happen. Hopefully my mic's been working the whole time. Okay, gotta find a new hiding spot for him. Hopefully you can't see him in the solar flare. Okay, goodbye then.